All right, if you're watching this at home, we're doing this little warm-up here. I've challenged them to, and challenge you to see if you can look at chart number 1, figure out chart number 2. Pretty simple once you see it, isn't it? Yeah, it's not too bad. A little hint is, and don't say it out loud, it's rhetorical. What does dy and dx mean? I've said it. I feel like I've said it a lot, but I teach this class 3 times a day, so it seems like I say a lot of things a lot, and maybe I don't. So what's that right there? What's the first x there? 2, right? Because the change in x is 2. So the x changes by 2, so we add 2 and we get 2. dy is 3, so this is 4. There's the first couple blanks that you fill in, because dx is change in x, dy is the change in y, so we're going to add that to the x and the y. Then we're going to add 0.2. This becomes 2.2, but to find out how did y change, well, that's 1.5. So that's 1.5. That's how y changed. Then we just keep going. 0.5 is 2.7. That's how x changed. Y changed by 3, so that ends up 8.5. Then x changed by 1. And then we're saying that y is changing by 0.4, so 8.9. And we could keep going on with that, but we're going to stop it somewhere. That's why those are blank. We're going to say, okay, we're done. We'll stop there. So it's just adding or maybe a little subtracting. That's it. So that's kind of the idea for today. It's called Euler's method. So students will be able to use Euler's method to estimate function. It looks like Euler's, but it's Euler. Let f be the function that satisfies the initial problem in example 7. They tell you what that is. Use Euler's method in increments of delta x, or change in x, as 0.2 to approximate f of 3. All right, so what do they want you to do? We're going to start at 2, at the point 2, 0. And we're going to find changes in x and changes in y, and we're going to try to estimate what f of 3 would be. And they tell you what the change in x is. It's 0.2. So we have to work our way to 3. 2.2, 2.3, 2.4, 2.5. Oh, no, by 0.2, excuse me. 2.2, 2.4. 2.4, 2.6, 2.8, and finally, we're going to get a value for 3. The problem with this, before we actually do it, is we are we're approximating values for a curve. But the first one, we're going to use the slope, because we're going to use the change in y, and we're going to use the change in x. And that puts the point over there when the point's really up here. Now we're going to use the change in y and the change in x to this point, but at this point. So then we go change in y, change in x, and we have the slope, and now our approximation just keeps getting worse and worse and worse. If you use big intervals, you're going to be way off. If you use very tiny intervals, then your error is going to be minimal, right? So if we're going to do 0.2 by hand, we could probably do delta x equals 0.00002 with a computer pretty easily, or even a spreadsheet for that matter. We wouldn't even need a fancy program. We could do it on a spreadsheet, and we could have increments that are very tiny. We'd have this super long spreadsheet because we need to get all the way down to the value, but our error would be very small. So just keep in mind that we're not doing very many intervals. A delta x of 0.2 is rather large, especially for the technology that we have now. All right, anyway, here's what we're going to do. We have dy dx. So the change in y is equal to x plus y times the change in x. We don't need the change in x. We already got that. We need how y changes each time. Grab your calculators. We're going to be using those quite a bit today. Oh, out. So dy is based on x and y and dx. So the first one is 2 plus 0 and then 2 plus 0, then times 0.2, which I don't really need a calculator for. It's 0.4, but let's get it in there so we can keep going, keep rolling with this. 2 times 0.2 is 0.4, and then we add that on to 0, and we get 0.4, of course, 0.4. There, that was the change in y. So we add that change in y to y, and we just keep repeating the process. So 2.2 plus 0.4, and then times by 0.2. So I did this piece again with the new point. So the change is 0.52, and we add that to 0.4. 0.92. That's the new y, 0.92. And it's only an estimate. It's not the right answer. It's the best we can do with the information that we have. 2.4 plus 0.92 times 0.2. Something was going wrong there, bad. All right, let's try that again. 2.4 plus 0.92 times 0.2. And we're going to add that on to 0.92. 1.584, 1.584. So then we're going to add that to 2.6, multiply by 0.2. That's the change in y. And we're going to add that back on to this y right here. The change plus the original y, or the previous y. So 2.4208. Last one, add 2.8, multiply by 0.2, add that back on to, where, here? Yeah. 3.46496 is what I'm getting. Hopefully I did that right. Might have hit some wrong buttons. I hope I didn't. Got the change in x, need the change in y. And we can use Euler's method to do that. What does this say? If dy dx is 2x minus y, and if y is 3 when x is 2, we're going to start with the 0.23, in other words. Use Euler's method with 5 equal steps to approximate y when x is 1.5. We have 1.9, 1.8, 1.7, 1.6, and they want us to approximate 1.5. The question now is, what is delta x? What's change in x? 0.1? Negative 0.1. There we go. The only difference in example 10 is they don't tell you what the change in x is, but hopefully it's fairly obvious that it's negative 0.1. That's how x is changing. Well, now the change in y is equal to 2x minus y times negative 0.1, or times dx. That's multiplying the dx over. So 2 times 2 plus 3, there we go. There's the 2x minus y times negative 1. Oh, excuse me. 7 times negative 0.1. That's the change, and we'll add that to 3. So 2.3. 2 times 1.9 plus 2.3, get that, times negative 0.1. So this, once you get it, it's just that it's tedious, right? Plus 2.3. So 1.69. Plus 2 times 1.8 times negative 0.1. There's the change, and we add 1.69. So it's 1.161. Plus 2 times 1.7 times negative 0.1. There's the change. Add that to 1.161. Oh, I missed. All right. This plus this. That's not it. Is it? Yeah, that's it, I guess. 7049 plus 2 times 1.6 times negative 0.1 plus 0.7049. So 0.31441. Questions on this? What's the matter, Will? Did I mess that up?
I don't know.
Okay. 2 times 2 plus, is it minus? Was I doing plus the whole time? I think I was. It's minus. Oh. Hey, that's you. Nothing funny. I'm just kidding. Relax. You thought I was serious for a second, didn't you?
Oh my God. Oh no.
Times negative 0.1. All right, so add to 3. 2.9. 1.9 times 2 minus 2.9. I'll get this. Times negative 0.1. Add that to 2.9. 2.81. 2 times 1.8 minus, this wasn't supposed to take this long, but I messed it up, times negative 0.1, and then plus 2.81. So we calculate the change, then add it to the y. So 2.731. So we got 1.7 times 2 minus, that's what I was doing wrong, 2.731. Get that, times by negative 0.1. There's the change. And we add it to 2.731. We add it to the previous y. So 2.6641. All right, last time we have to do this. Here we go. 1.6 times 2 minus 2.6641. Multiply that times negative 0.1. That's actually the change in y right there. And we add it to 2.6641. 2.61051. 2.61051, I think. I hope so. On every test that I've ever seen this on, it just has you do this twice. So this is a lot for what a test is going to ask you to do. But the answer is sitting right here. That's what we're looking for. Specifically, that number is what we're looking for. And it's only approximation to the curve. It can't be exact because we're using tangent lines. Let's try 55 here. Use Euler's method with increments of delta x is negative 0.1 to approximate the value of y when x is 1.7. We start out with this point right here, 2, 1. And change is negative 0.1 for x, so 1.9, 1.8, 1.7. Now dy, the change in y, we have all the x's. The x's are done. What we need is the change in y every time to get the y values. That's going to be 2 minus x dx. So the derivative is only based on the value of x. It has nothing to do with y this time. Well, now we need 2 minus 1. Oh, excuse me, 2 minus 2, the x value, which is 0, of course, and then times, and I know it's going to be 0, but negative 0.1. So the change is 0. So that's still 1.91. 2 minus 1.9 times negative 0.1. The change in the y now is negative 0.01. We add that to 1. So it's 0.99. All right, one more time. 2 minus 1.8 multiply by negative 0.1. And we're going to add that to 0.99. So the approximation is 0.97. So here's our answer. 1.7, f of 1.7 is approximately 0.97, which is not correct. It is an approximation. So what if we, now in the homework, we're done. It's 0.97. However, what if I said solve the differential equation? What if that was the instructions for this problem with this initial value? Go. Do you know what that means? You have any clue what it means when it says solve the differential equation? And I've argued it, I've told you already, I think I told you on Friday, that students get these instructions on the test and they have no clue what to do. And I know we only covered it one time. So if you're sitting there going, yeah, I don't know what to do either, that's fine. It just when we get to the test, you have to know what those instructions mean. I'm right, aren't I? Students have no idea what those instructions mean. And you're sitting there going, geez, give me a break. We covered it on Friday, and then we had the weekend. I know, I get it. You have to know what this means by the time we get to the test.
The answer is elephant.
What's that? Elephant. You got it. That's a callback from an earlier day. Split the differential. Integrate, right? Next is integral. Y is equal to 2x minus 1/2 x squared plus c. Use the initial condition. So 1 is equal to 2 times 2 minus 1/2 times 2 squared plus c. 1 is equal to 4 minus 2, 2. So c is equal to negative 1, and now we plug that back in. So 2x minus 1/2 x squared minus 1. There is solving the differential equation. In other words, back up, find out what function has this as a derivative and passes through the point 2, 1. Now the reason I do it on this, well, we couldn't do it on the other two, because if you can't minus the y over and have x dx. This doesn't make any sense from what we know and what we can do in this class. So some of these you can't solve. This one we could rather easily, as long as you know what the instructions mean, of course. So now my question is, how far is this off? How far off is this? Well, let's plug 1.7 in. Let's find y of 1.7, because now this is the actual function. 2 times 1.7 minus 0.5 times 1.7 squared, and then minus 1. So the actual answer is 0.955, which, believe it or not, is very close considering we only did 3 steps. We had a huge interval. 0.1 is huge, and it's still fairly accurate. So hopefully that kind of gives you an idea of what's going on. We are only making approximation, but when we can actually solve them, well, we can find the value. 56 we would not be able to solve. The best we can do is an approximation. All right, try 56. So you think the y's went 0, 1, 2, 3?
Yeah.
Okay. That was an easy one. So we start out with what, 2, 0? So dy is equal to 1 plus y times negative 0.1. Did you do the negative 0.1 part?
No.
I didn't think so. I kind of suspected that. 1.9, 1.8, 1.7, 1. Oh, is it 1.7? Yeah. So if I take this off, that's Jacob's rule for doing Euler's method. It's Jacob's method. I like your method. It's way easier. No decimals, don't have to worry about decimals at all. I love it. One plus 0. Okay, so it's just 1 times negative 0.1. That's the change. We add that to 0, you get negative 0.1. We're going to add 1 to that, right, to the y. That's the new y value, so plus 1. And then we're going to multiply by negative 0.1. That's the change. We're going to add negative 0.1, negative 0.19. Let me know if you got something different, if I'm hitting wrong buttons here. That's the y, plus 1, times negative 0.1. There's the change. And I'm going to add on to negative 0.19. So this is what I'm getting. Negative 0.271. Now we cannot solve this one, so that's the best we can do. Well, it's not the best we can do. We could grab a spreadsheet, we could make the interval super small, and we could have a really good answer. But this one's good enough. That's what we're looking for. Any questions on Euler's method? That's the new stuff from the section. The rest of those are old, from Friday. So only 1 day old. Well, over the weekend. Anyway, I teach a computer programming class, and I wanted to write a program to group you guys up into random groups so that we just don't turn around. We mix it up a little bit when we can do groups in here. And I sent it to my brother. He programs for a living, so he sent one back. That was much better. So here we go. This is 6th period. I'm going to bring you up to the board, and just one person. And it's going to be the first name that pops up. Okay, first name. So we're not going to do groups, just the first name that pops up. You ready? Who's it going to be? Parker. Where's Parker? Oh, there you are. Yeah. Yeah, you're up.
Wow, that is so scary.
Okay, we're going to help him. You guys, are you going to write this down? This is notes. Here we go. Oh. All right, you're going to solve them. So you're going to split the differentials. Get y's with dy's, get x's with dx's. He's eye level with this problem. I got to look up to that. How tall are you? 6'5". 6'5", yeah. Jeez. So am I. Okay. No. You split the differentials. You gotta get the y minus 1 squared over to the other side. Oh. Yeah. Right. Okay. Why don't you just erase that? Perfect. Okay, now integrate, right? We're going to integrate. And I'll help you with this too. On the next line, let's write this. Integral sign. On the next line, integral sign. Y minus 1. No. Oh, sit down. It's not your fault. I think last periods I did this one, and then I had students do the rest of them. Not your fault. Y's with dy's, x's with dx's. Integrate. So the integral of y minus 1 squared dy is equal to 1/2 x squared plus c. Negative 2. Negative 2, right? Because we're bringing it up to the top. We're going to add 1, and that's going to be y minus 1 to the negative 1. But now if we took the derivative of this, we'd have a negative value. We don't want that. We want it to be positive. So there's your antiderivative. This is negative 1 over y minus 1 is equal to 1/2 x squared plus c. So we took the integral, and I kind of just simplified it a little bit. Let's use the values. Negative 1 over negative 1 minus 1, because the y is negative 1, is equal to 1/2 times 0 squared plus c. So the points are that, for this problem, if this is on your AP test in May, are big points. There's 5 points for this. I can't think of any other problem, any other single problem that's worth 5 points. They're usually worth 3 and 2, and some are just worth 1. This is worth 5 points. One of the points is showing that you're using the point right here. So we can all do this in our head, but don't. Write it down. Negative 1/2, 1/2. So c is equal to 1/2. And you get a point for just finding the correct c also. So we have 4 of the 5 already done. The 5th one is probably the most work, and you only get 1 point for it. We're going to plug the 1/2 back in somewhere for c. How about right there? Negative 1 over y minus 1 is equal to 1/2 x squared plus 1/2, right? Plus, yeah. Getting the last point is what students typically have the most trouble with because it's algebra. The calculus part in calculus is usually the easiest part. Usually the toughest part is the algebra. All right, so my challenge to you now is get y by itself. I can do it, but so what? So what if I can do it? It's pretty buried too. Can you get y by itself now? Then I'll show you how I would do it. How I'd finish this problem. Parker, I should have done this one first before I sent you up there. That's my fault. That's my fault, not yours. You're going to have to multiply by 2, and you can either multiply by 2 now or multiply by 2 later to get rid of these fractions. I tend to do it now. See how it makes it kind of nice and clean? Cleans it up a little bit. Now we're going to multiply by y minus 1 and divide by x squared plus 1. So they change places. So y minus 1 now is equal to negative 2 over x squared plus 1. And just add 1. Now you could probably do common denominator with this, but there's no reason to. There's no reason to do common denominator there. I would just leave it alone because we're not trying to find where this is 0. That'll never be asked. We just want the equation. All right, you got a good idea what solving a differential equation means? What those instructions mean now? That's important. All right, now I need a victim. I mean a volunteer. I'm going to get some up here. You ready? Oh, I hope it's you. I hope it's you so bad. How many times should I run it? 4? 4 times? Okay, 4 times. Here we go. 1, 2, 3. Okay, ready? Mason! All right, rest of us are going to do it too. I'm going to clear this out. Everybody good? Everybody got it if you want it? Okay, let's clear it. Here you go. You can start to the left if you want. You don't have to start under it. Oh, someone else did this too. What's wrong with that? I mean, it's just a technicality, but what's wrong with that? It's y dy, right?
Oh.
Yeah, but that's kind of your grouping symbols, is your integral sign and your dy is kind of your grouping symbols. So just erase the left side for me. And put integral of y dy. There we go. It's pretty much what you had. No, not necessary. Nope, we're good now. Perfect. All right, he just earned a point just for plugging in the values, right? Oh, did you mess that up?
Did I?
Yeah.
Oh, I plugged in.
Yeah. Put a 6 there. There you go. So I guess that's the good news about this, about showing you're using the point is pretty simple point to get as long as you just write it down. There you go, perfect. Very good. All right, C's 8, good. C is 8. Welcome to my world. There you go. I love it.
Is that it?
Is that it?
Yes. No. No. Oh, do I need to plug in 64? Should I make it?
No one's going to help him?
Is that plus 6?
What's that?
Is it?
Yeah, that's fine. Nobody's going to help him?
Is it like find closest plus or minus?
Yeah, there you go.
Oh.
Is it plus or minus?
Plug in minus negative 4.
Right, it's minus because it's negative 4. If it's positive 4, then it'd be positive. So the only way you can square root something and get a negative is if the negative's out in front. So you have to either leave it alone, that'll be the plus, or put the minus, and you're right. It's negative because it's negative 4. Give him a nice round of applause. Good job. Yeah. What's that? See, note, are we out of time? No, we're not. Nice try, though. Nice try. How many? Let's go twice. 2 times.
I feel like the first one's going to be Alex, though.
Ooh. Here we go. Oh, wow. Come on up. It's fate. It was meant to be.
I'm getting some of this. I don't want to go.
Perfect. Oh, okay. I'll tell you what, make it y to the negative 1/2, right? Y to the negative 1/2. There you go. Love it. I love that you remembered the 2. Perfect. Put plus C on the right side.
Oh, yeah.
It's one of my favorite things about teaching you guys is you guys know fractions. That's such a relief. I hate teaching fractions. I think if you're a senior in high school and I got to teach you a fraction, it doesn't sit well with me. Shadows suck, don't they? It is. You were doing so well. That is so wrong.
Cancel the square, use square instead of square root.
Oh, shoot. That's unfortunate.
Yes, it is, isn't it? All right, let me help you out. Go and keep erasing that. Erase both of those. Now, here's what I want you to write. See that last line that you have? Well, right here, right where it says plus C on the 2y to the 1/2. So not the last line, but right next to it, right there, that line. Write that line over again with 11 halves in for C. And then I'll bet you get it. Plus 11 halves. Okay, run the 2 through now. So multiply both sides by 2. Or excuse me, 1/2, right? I said 2. I meant 1/2. Right? That's my fault. Okay, so y to the 1/2 equals what we got? 1/4 x squared plus 11/4. Well, now what you did is you square rooted to get rid of a square root, right? So now we're going to square. We're going to square both sides. So y is that whole thing squared. And then you got it. Yep, absolutely. That squared. All right, give him a nice round of applause. Good job. Good job. Excellent. Last one. We got time. Oh, we got lots of time. Kidding me? How many? We're on 2? 3? We want 3. Oh, you want 1. Just 1. I'm going to go. We already did 3. We're going to go 1. We're going 1. That's it. We're going 1. Will, you're up a couple times. Yeah, it wanted you for sure. All right.
Can we put Mr. Smith on this one of that?
I do it all the time. All right, write it down now. Play along. Not necessary. Erase that. Don't do that. No, not necessary. What's the antiderivative when the denominator is to a power of 1? That one's the natural log. Yep. What's that now? Yeah, if you add 1 to it, you're going to get 0. So that's why we don't want to do that. You're not following me? No. Okay. I'll just go off to the side. You're not off the hook yet. Okay. If we have 1 over y minus 2 to the third, and I make that y minus 2 to the negative 3, and we add 1, we're still alive. We're still in the game. Because then that's negative 2. I'll make that negative 1/2, and we're good to go. That's the antiderivative. If we have 1 over, in our case, y minus 2, and we make it y minus 2 to the negative 1, now what happens when we add 1? That's going to be y minus 2 to the 0, and now the derivative is going to be 0, which our derivative should be 1 over y minus 2. So what we're going to do to this one is we're going to make it natural log, because now the derivative of this is 1 over y minus 2. Does that make sense that way? Okay, all right, very good. Plus c. Yep. We're not going to do it as a decimal. Just we're going to say it's natural log of 2. So c is natural log of 2. Or equals c. That's fine. There we go. What do logs always equal? Logs always equal the exponent, right? So all that junk over there on the right is the exponent. Yeah. So let's go y minus 2 e to the all that stuff. All right, nice round of applause. I'm going to alter this a little bit, but I'll do it. So right now he has y equals e to the x to the 5th over 5 plus a natural log of 2 and then plus 2. And now, if this was a free response question, you could leave it like that. It's an equivalent form to the answer and no problem. You got y by itself. But if this was a multiple choice, this probably wouldn't be the answer. Or you'll probably see something like this, where this is times e to the natural log of 2 plus 2. Remember, when you multiply, you add the powers, so we can split it back up into multiplication. And then that right here is 2. So the answer you would see on the rubric or in multiple choice would be this. So you better be able to get it to that, just in case it's on multiple choice. You have to be able to simplify it like that. Any questions on finishing it like that? All right, good job, you guys. Thanks for coming up. Thanks for playing along. Yeah, I'll help you. We'll help you. Don't have to be afraid of it. All right, Alex?
Uh-huh.